Welcome to another presentation, a brief presentation on self-sovereign identity. Um, uh, the agenda was basically we're going to identify, or in this case, explain briefly what sovereign identity is, or SSI. What's the technology behind SSI, and how to architect SSI-based software. So in other words, how to put all these things together to have an application that can work in a real world situation. So first, what is self-sovereign identity? Human identity is a complicated topic. It's not easy. It's hard to comprehend and wrap your head around it. So first, it has to be addressed in terms of historical points of view. You know, how did it get to where we are now? So first, you have intrinsic identity. This is basically the true form of identity. This is what represents each person, basically. Some of the largest ways in which we today represent identity, in this case intrinsic identity, is using social media, blogs, and other internet platforms that basically exist to help us express our intrinsic identity, so who we are. And we have the extrinsic identity. So this is how others perceive, often institutions define us, as individuals. So how others not only perceive, but also how others identify us, basically. So we're using, in this case, we use government. It helps in doing this. But there's no good way to manage this extrinsic identity, digitally, until the advent of SSI, or in this case, until the advent of blockchain technology, which facilitates the deployment of this. So another way to explain this is basically we have these components, or in this case, identity. This is another way to say it is I think, therefore I am. It's the actual individual. So that's what we call identity. The next definition is the identifier. The identifiers are the name of the person, for example. That's one specific identifier. The email, the social security, the ID number. These are identifiers. The date of birth. These are identifiers that fall under a specific identity. So identifiers basically point to an identity. So they're identifiers, specific points of data that point to an identity. Attestation, on the other hand, is the word that usually the authorities, if somebody in authority is indicating that an identifier, specific identifier, has certain rights or certain licenses in this case, or license, for example. So an identifier might be, implies the role, for example, of a driver, or a pilot, or a teacher. And this is where the role comes into play. It could be a graduate person that graduated from college or high school, or a certified auditor, for example. These are roles. So these are definitions, and we sometimes misrepresent or mischaracterize some of these definitions. So it's good to have this out there so we understand where all of these terms fall into. So the SSI is basically a model that claims, or manages digital identity. So all of these identities, or identifiers, or these terms, all this has to be managed by something. And up till now, it's been managed in a completely different way. We'll see how these two differentiate, and basically how it should be. It should be as legitimate and evident as a human identity. So the idea that's behind the SSI model is to manage this. Now, up till now, we've realized that we have a paper credential model. It goes back in time, but we've used some kind of from modern times. We use license IDs with a physical ID, but in the past it was just a piece of paper with some kind of stamp on it. So it was a specialized ink, specialized, in this case, some kind of material that guarantees the authenticity of the paper or the certificate. So this is basically how we've evolved. Let's call this model the 20th century model, basically. Where we have the government, let's call this is what we call the issuer issuing these credentials. Then you have a holder, this is the user, the actual identity, the I and I am, that I think therefore I am. But the issuer then recognizes this holder and issues a license or some kind of credential. Now the verifier is the one that looks at the issued credential that the holder is presenting and verifies to make sure that they are who they are using different technology. So what it does, it proves who issued the credential. So the verifier is looking at this credential identification, and it's looking at see who actually issued that, and then it looks at who holds the credential, but maybe the picture that's in the that's one way to verify that person is who they are, and that any claims have it on chain. So this whole process accomplishes these three things. Now, in case of the paper in person trust, which is the traditional way of identifying an individual, for example, the key here is the question is how we make trust decisions. So we're trying to decide, is this document valid? Is it the person that's in front? So we have to use certain technological tools that are embedded in the certificate, in the paper, whether it's a picture, whether it's a hologram. In the case of the note of the $100 bill, for example, there's a lot of features in it that prove the authenticity, prove that it is $100 and it hasn't been forged. So the question is it a legitimate representation? Does it represent $100 of the U.S. dollars, or in the Canadian dollars from Canada? It hasn't been forged or changed. So all of these things are aided by technology. Now the next step is, okay, governance. Is the source of this representation of this technology trustworthy? Because it could be the company behind is completely a farce and issuing these things. So they could be very technologically advanced. That's correct, but the actual institution issuing this is not trustworthy. Where does the authority come from? Is it from the government? Is it a third party? So all these questions come up. And is there a process to guarantee this type of trust, for example, or try to provide a trusted process, basically? So then we start, what about we live in a new digital credential model where we do all these account-based models for issuing credentials and digital. So the challenge here is, do you trust the issuer? So is the issuer trustworthy? So that's the challenge here. So we go back to the same diagram here, where we have the issuer issuing in a registry, some kind of database, where the holder provides these issue credentials, and the verifier, in the case of the bank, verifies this using some kind of database or something that's on the internet. So this proves who issued the credential, who holds the credential. The claims are unchanged. The claims have not been revoked. So that's another degree of digital credential, is that these claims have not been revoked, because now you're checking real time on some kind of account or some database through the internet in a secured way, but you're looking at a database and it's looking on probably real time. It'll tell you that the credential has been revoked. So these are the digital certificates, for example, that you have on websites. Okay, so that's where we are now. So verifiable credentials, on the other hand, is what we're trying to solve, which is this cryptographic protected data that proves you are who you are. So now the actual holder of these credentials can prove mathematically that they are who they are, because they hold the issued keys that had been issued to him or her. Cryptographically protected, equivalent of a paper credential. So if you do have a paper credential, it could be cryptographically protected, because now you can use this technology to put it in your phone. So and these are carried by the holder on a smartphone or a computing device. But I'll keep in mind that very important thing is that these credentials, in the case of these secrets that the holder holds, are not on the blockchain. They are on the phone. So the user has to obviously back these things up. But they have control of their credentials. What you have on the blockchain, what the blockchain is all about, is those documents, those data that only the issuer, in this case the controller of these secrets, can use these secrets to unlock and prove that they are who they are on these information or data that's on the blockchain. That's one of the differentiations here, right? The phone does a lot of work on the holders as a holder's agent, because the smartphone is like an agent. They only are there to establish this cryptographic exchange with the blockchain or with other parties on behalf of the identity, or using the identities that are identifiers inside the phone. So SSI is the new standard for digital trust. Basically, that's what it boils down to. It's a digital identity, it's a human identity. So the humans, the holder, has all of these credentials around them, and it all revolve around this one identity, in this case, this one holder. What self-sovereign identity does, it allows this same functionality but accessible to all. This is where the distributed ledger comes into play. Now, it also has the privacy preserving feature, which is the core of this technology, because it uses cryptography primitives to make sure, in other words, math, to make sure that the holder is the only one that can divulge this information. And so providing that privacy that individuals require. But the key here is that it's privacy preserving from the core of the technology. It's also not reliant on a single government or corporation. So now, because you're not holding these credentials in multiple locations, in the government, in the banks, in the agencies, this is no longer the case, because it's on a decentralized ledger. Now it's distributed throughout the network with the control of the holder. So the holder is the only one that can update or issue any new or changes to those credentials. So what's the technology behind SSI? The core concepts: you have agents. These are either smartphones or websites that provide the ability to exchange this information on behalf of the identity, in this case the holder. Then you have verifiable credentials. These are credentials that are on the blockchain. They're on this, let's call it distributed ledger or distributed database, where these verifiable credentials are, and the agents can go into and talk to this database and be able, with those on behalf of the identity of the holder, is able to verify these credentials in that. And these are contained within what they call this decentralized identifier. So these are the DIDs. So all these specific pieces of schema of data are presented and placed into the ledger, which is the next. Says it's the blockchain or verifiable data registries, where these DIDs are registered. But only the holder of these identifiers is able to prove that they are who they are. And that establishes correlation and privacy, because you have these type of things, you can correlate all the data registries to a specific identity, and they can be connected all together, right? Using the blockchain technology. And because of the cryptography behind it, you can also establish privacy. The traditional systems have been known that they have the ID issuers that issue credentials on, up to now, it has been on SQL servers, some kind of centralized servers. And you have two parties. You have the holders, the actual identity holding identifiers, and you have in this case, financial institutions like banks, for example, that want to verify these identities, right? So all these players are actually putting all their information and exchanging all their data within a centralized SQL server. So this basically points to the traditional client-server environment where the server is the central point of failure. And this is a challenge to solve because we cannot move forward into a 21st century modern platforms by having some of these issues and challenges in case of data being centralized. And this is depicted in this picture where you could have multiple governments, for example, multiple institutions, and they're all holding all these different databases, but your identity or identifiers could be duplicated in all these different silos of data, right? Of course, you can have multiple identities in different places, but if they get hacked, they get compromised, you might end up compromising, and we see it all the time. People's identity gets stolen. There's services out there that go out there and start cleaning up this duplicate data and try to mitigate as much as possible. But it's a system that has been grown up to what it is now. That doesn't have to be this way, and this is where the SSI type systems come into play. Now, the SSI type systems have the same kind of requirements, which are the government issuing, and in this case, the government has a wallet. The individuals have wallets, and the financial institution, in this case, as an example, have also their own wallets. Some of them don't, but the point here, the wallets contain the secrets, right? And this is where wallet secure cryptographic keys, and secrets needed to authenticate relationship and share verifiable credentials are stored. So the wallets come into play because now if it's the issuer or the government, or if it's an individual or the financial institution in this case, they're able to have control of their identities. And they can exchange communications with other peers in a peer-to-peer network using cryptographic keys and using these wallets to verify who they are and establish that communication. And this establishes what they call a relationship-centric with encrypted messages and mutual authentication. So there's no centralized way to establish this relationship. You have the relationship is centric as the core of the system, but it's decentralized in the way it gets applied, right? Because everybody can talk to each other using their own wallets to encrypt and decrypt information and messages. So this is a very simple data flow of how this would work. You have the issuer on one side. This is let's call it the ID agency. The issuer verifies a specific person or identity, for example, and they have pictures and everything, and they put that individual, package it up all together, and basically issues it to the register, to the database, right? But now in this case, it's a distributed ledger, this decentralized distributed registry, where this data goes and gets issued. But then what it does is says, okay, we're going to issue the credentials to the holder, to the actual person that is represented by these identifiers. And here what happens is that the ownership of these, let's say the private keys, are being transferred over, or the ownership of the holding, the person controlling these credentials now becomes the holder. So now the holder has possession of control of these identifiers, not the issuer anymore. The issuer just issued them, put them in the. Now, the holder can then decide to say, I want to make some changes. I have a new picture of myself. I cut my hair. So I have to send a new picture, for example. So that gets registered. So that's why the holder is able to also issue into the register or make changes into the register, because they're the holders and the owners of that possession. But then in the example of the financial institution that wants to verify this holder, open an account for them, what happens is that the holder then says, okay, I'm going to present my credentials so I can prove who I am. I'm providing identity, right? So I present that to the inspector or the verifier. In this case, it happens to be a bank. But they're only requiring, we need to know your date of birth, we need to know your address, basic stuff, your name, things like that. That's all we need to know. We need to know nothing else. So the holder presents only what's required. Once this is presented to the verifier then goes to the database, in this case the registry decentralized database, which is in this case a distributed ledger, the blockchain, and goes out and picks that specific DID, brings it over to them, and compares the signatures, compares what's presented to them has a signature, right? So it compares the signature with what's on the blockchain, which was issued by the original. So only the true holder will able to sign that document with their secret keys and result in a signature that they can compare against what's out registered. And once they do that, they compare the two signatures, they're correct, and they will open the account. So this is an example of a simple digital flow. All of this has been done by the what they call the TCP trust over IP stack. And it's a layered type of stack, very similar if you've known about the OSI model back in when the internet was being developed. They had to have standards for communicating between computers. So they created the OSI model, which has the TCP IP stack and all these different layers from the IP all the way up to the application layer. Well, this is very similar. In this case, there's 4 layers. You have a trust over IP governance stack. So this is the actual governance of the stack. And then there's the trust over IP, the technology of the stack. So the technology and the governance. Layer 1, in case of the technology, you have your public utilities. These are your blockchains. So whether it's Hyperledger, and we'll see an example on one of the slides, whether it's Hyperledger or Microsoft, or Bitcoin itself, or in the case of Microsoft is using Bitcoin itself, Hyperledger is using its own blockchain, and there's also Ethereum that uses their own blockchain as well. In governance, you got stewards, transaction endorsers, people put the transactions in. In technology, you move up the layer into the peer-to-peer. That's where the agents come in. This is where you have the interaction between the smartphones. So this is the software providers providing this governance. Moving up to the data exchanges is where the verifier verifies with the issuer goes into the holder, and the holder proves who they are and all that stuff, and this trust gets enabled. Again, this is the issuer layer. And then you have the application layer at the top, where it's all the different applications that can use this innovation. And it's governed by auditors and members of the directories of these type of it. But this is at the layer 4. Very similar to the OSI model. So how to architect this type of software is basically you have this type of layers, and understanding this layer you have down at the bottom, starting with the blockchain, is where your DIDs are, where your standard schemas are, credentials are, and then you have an agent layer, which is where your phone is, where your websites are, and they all interconnect to each other and in a peer-to-peer way. And then you have the credential exchange up at the top, where you have the issuers on one side, and then you have a really existing trust relationship with the merchants in this case, for example. And you finally have the holder. The holder gets issued a credential, and then they prove back down. All of these things are handled by different players in the ecosystem. And for starters, what we have now is we have the blockchain part is being done by Hyperledger. It's a community of 250 individuals, contributors. It's production ready. It's being used right now as we speak. And then you have another layer on top, and this allows it to scale. This is where the architecture can really scale, is using, again, Hyperledger, different aspects or products of the Hyperledger, and their blockchain agnostic, interoperability between projects and all that. So this allows it to say, you can use Hyperledger, but we can also be interconnected with other blockchains out there as well. And this is at a layer 2 and 3 part. The SSI architecture components are basically, you have the agent services exposing functionality through the REST API. These are most of these terms are actually for developers, but basically what it means is that you have these agent services. In other words, agents think of the smartphones or a website, they will talk via API or application program interfaces into the applications using these agent services, right? Each agent services, one of them could be mobile integrations, and that usually means that it's a service as a public endpoint for mobile agents. So that's one of the aspects of the mobile integrations that the architecture has. Then you also have cloud agent scenarios where they're managed agents with user wallets. For example, in this case, some of these individuals that have an identity might not have a wallet, a smartphone. So then you end up with some kind of way in which you can then go into a website and log in to these managed agents that they themselves have user wallets that interact with the blockchain. Basically, the cloud agents become custodians of wallets managed for either by organizations or by other entities. So the idea here is that the cloud agent is the actual custodian of the wallets. They are the ones possessing the wallet. But it's a matter of trust relationship that you would have with an institution. And then you finally have the actual blockchain, which is the verifiable data registries. This is where the DIDs get resolved, for example. And in the case of it's what we call the ledger itself. You have Sovereign is one of them that using the Hyperledger. Ion, it's its own platform that runs on top of Bitcoin or gets verified by the Bitcoin blockchain. And you have others out there like Ethereum also in this game. So this is an example of a verifiable credential. Very simple way. It's another example of what we've been talking about, where you have on one side you have Alice going from the top. It's trying to log into a website. So what happens? The first step is that Alice says, "Okay, I'm going to register a new account. I'm going to give them my name, my email, etc., and I give that to the website." So this is like a registration process, right? And that registration basically gets input into the website. The website or the institution then says, "Okay, I'm going to issue a verifier." So they become the verifier. I mean, the issuer. Sorry, they issue this verifiable credential that they have verified with Alice information, and they put that in the blockchain. So that's the first step. It gets issued. So what happens is once it gets issued, they basically have possession of this credential, but now they have to give that credential over and send it to Alice. And what's happening here, credentials can be sent by either QR code or links on the mobile app, whatever. But what's happening here is that the control, the possession of this identity is now going to the actual holder because it's been issued by the website. So the website, the entity, that's what they do. They issue these things. So they issue that. So no longer does the website, even though they issued it, they no longer have control over those credentials. Now Alice has. So that's very key, very important to understand. And Alice stores the credentials in their wallet. So now she makes sure that she backs it up. She makes sure that she has she's able to restore it if her phone dies, etc., etc. And some of these mechanisms are built in by the agents into these smartphones. The solution basically makes it easy for the user to accomplish this. So now that Alice has the email credentials, she can now log into a website. So now she moves into the authentication part, which is she starts to log in with a website. Could be a different website, could be the same website, doesn't matter. But the point is that once she starts to log in, there's a request for proof of credential presentation. So the website then goes back to Alice and says, "Okay, can you prove who you are? We need to know more information. So we need to know first of all, we have to start communicating. So now we're communicating from website to, in this case, a smartphone, exchanging public-private keys, or public keys actually, to start that communication. Once that gets done, then the website is, okay, I need your ID, your name, etc., to see and prove to me that you are who you are. In other words, sign a piece of paper saying who you are and with the information you want to present. So the website sends a request for verified presentation to Alice, asking for some information from her, and the presentation can be in the form of QR code, for example, that make it very easy. So Alice then prepares that verified presentation. She basically presents whatever was asked to be presented, and sends a verifiable presentation. In other words, she signs that verifiable information, sends it to them. So now there's a signature associated with this that was generated from her private keys that are in her phone. The signature goes over, and this verifiable information goes to the website. The website is okay, fine. I'm gonna let me go and turn around and go to the verify this presentation is valid. So in other words, they're going to the blockchain and grabbing that signature that's on the blockchain, it's a public signature, and see if they can compare what they have been issued by or verified by the presentation that Alice is presenting. Does it match? Is the signature correct? And if that is correct, then they say, okay, great, this is Alice. This is actually Alice, and she's presenting the right information, so we're going to let her in. No password needed, no nothing. It's just as simple as that. So just to review, you've got registration part, which is the creation of the create account, basically, or task. It collects the user information, name and email, etc., and then it issues a credential that gets, ownership of that credential goes over to the holder. In this case, Alice. In practice, when Alice wants to, the login users, so the process of logging in, the reverse goes in. The request goes verifiable presentation, proof of name, email, etc., whatever is required, and it says, okay, show me and tell me who you are, and that verified presentation comes back to the user to the website or the login page, where they can use that verified information to go to the blockchain and verify if it's correct. That's basically it in a nutshell. Hope you enjoyed the video, and we'll see you in the next one.